So, this is the Earth. This is not Mars, but this is kind of a classic view of what sand dunes look like here on the Earth. This is actually a site in Vietnam. Here is Namibia. Huge sandbox. Here's Death Valley in the States. White Sands in New Mexico. Huge dune fields around there. I have photos, but they're from long ago, pre-digital days. We won't take a lot of time going into this, but basically, dune fields are landforms that are generated by wind blowing across the landscape, picking up sediments of different sizes, and moving those sediments along. And based on the prevailing winds and how constant those winds are and the source of loose material, you can get different kinds of dune formations. And we won't look at a lot of them, but I do want to talk a little bit about these barchan dune structures. In particular, these are very kind of classic dune field perspectives that you can see from aerial photographs or satellite photographs on the Earth, and we can see them in images from orbit as well. But depending on whether the if the prevailing winds don't have a prevailing direction, but they're blowing from different directions at different times, you can get much more complicated these star-shaped dune formations, as the winds blowing in different directions are going to be moving these sands along in different ways. These are fluid structures, generally speaking. Dunes will migrate across the landscape unless something happens to fix them into place. Now on the Earth, we can get dunes fixed in place by having plants grow in them. If you've got dune grass that has germinated onto a set of dunes by, say, Lake Michigan, the roots of those dune plants, the dune grasses, will obviously help to stabilize the sand in place, and it won't blow around. But you can also get dunes fixed in place by just chemical processes. So if there are salts that are the deposition, the precipitation of salt grains can cement these sand particles together, and that will also tend to fossilize or fix the dunes in position. Again, it's these barchan dunes are kind of the classic structure. Basically, based on the size of the particle, small particles are going to be picked up by the prevailing winds more so than others. If particles are large enough, the wind will just kind of blow those particles to creep them across the surface. But the smaller particles will actually be picked up, be blown for a little while, and land in this process called saltation. So if you've been at the beach on a windy day, and you've got shorts on, you might feel all of these little sand grains hitting you in a boundary layer that's close to the surface of the beach. The leeward side tends to be this steeper part over here. So the windward side, the wind is coming up this way. It will blow those sand grains up this more gentle slope, and then they'll fall down on the leeward side, the slip face of the dune, and you'll have this much more steep morphology there. You see dunes and sand fields all over Mars. Here is just a view of Victoria Crater, where Opportunity spent a lot of time. And you see this kind of reticulated pattern in the middle of the crater. This is this more kind of star dune formation, because the winds are going to be blowing in here from all different kinds of directions, and the wind's going to be swirling around in the crater. So you're not going to get that classic dune morphology in the middle of craters like this. Here's just a view from Opportunity. You can see all of this loose material that is basically being blown around into this dune field. Now, Opportunity did go down this slope for a little bit in order to survey and sample the walls of the crater, but for obvious reasons, I guess, they did not send the rover down into the sand, because they were concerned that they wouldn't get the rover back out of the sand. Here's just a channel that is being in the process of being engulfed by a dune field. You can see this kind of classic ridge after ridge after ridge of dune field here. We've got basically the sand is being blown in this direction, forming this this structure. With long-term satellites in orbit, we can actually see changes in the dune ridges over time. No big surprise. Here are some dunes at the South Polar region, or North Polar region. Defrosting in the spring. Just lots of pictures of dunes. Of course, has a bunch of them. This is kind of a a whole field of these individual dunes. You can see that the prevailing wind in this area is going to be coming from this direction. So not only are these perhaps aesthetically pleasing, but by looking at the structure of dunes on the planet now, you can get an idea of what the prevailing winds are without having a weather station sitting here measuring the winds from day to day. Here we have, again, barchan dunes kind of crawling across the landscape. Which direction are they going? Yeah. Yes. Yeah, well, we don't know that that's north, south, east, west, but from right to left. Yeah, okay. This is actually a set of dune fields as well. Spectacular. This, I think, is again back a close-up of the bottom of Victoria Crater. Just kind of a landscape art picture.